Hello guys, welcome back to US Healthcare Academy. Today I'm going to talk about master data management, a small part of master data management, which is patient matching or entity matching. Now, what is entity matching? So let's look at this patient's table here on my screen. Uh, Look at the patient ID 1003. First name Robert, last name Johnson, address 789 Pine Road, and some date of birth 1965 December 10. Now I have a duplicate record for this patient, but with another patient ID, which is 1011. And look at the last name, it is spelled a little different. So here it is Johnson, here it is Johnson with double N. First name is Robert. First line of address is 789 Pine Road here, and road is spelled completely like ROAD, and the road here is spelled like RD. So these are very common use cases in healthcare where if the same patient record is coming from different sources, there's a possibility that there are spelling mistakes, or address lines or addresses are spelled differently. One record has an old telephone number and one record has a new telephone number. So those are the discrepancies in the records, and because of which it becomes really difficult to identify those two records as one patient, and which causes downstream effects on analytics and computation of measures, etc. So to give you an example, on one patient record for this measure called uh, controlling high blood pressure, where the denominator says that the patient needs to have a diagnosis of essential hypertension, and the numerator says that the blood pressure has to be measured. Just imagine that we have one record which is 1003 where the diagnosis of essential hypertension is documented, and this another record 1011 where the numerator condition is documented. In this scenario, what happens is 1003 qualifies for denominator but does not qualify for numerator, and which causes inaccurate performance scores for that measure. So that is just a one simple example, but there are a lot of other use cases where it is important that the patients, the duplicate records are matched and merged together. To overcome this challenge, I'm going to show you today how I have made use of AI. So let's see what we got here. So I have this MDM pipeline that I've created. Okay. Now, firstly, there's a MDM config file here, and it has something called as rules, where you can define certain rules here. Okay. And you can define multiple rules. So basically what this rule means is there are keys in this rules, which are nothing but the columns in our uh, in a patient's table. So first name, last name, street address, line 1, date of birth. So what we do is we tell the system that, hey, I want to match the patients primarily. So rule 1, it will execute an order, and it will find the matching records for various rules here. So rule 1 says that I want to match the patient on first name, last name, date of birth, street address, line 1. And the rule 2 says that I want to match the patients on first name, last name, date of birth, and email address. Okay. But remember, in our case, this is not deterministic matching, which means that we are not going to match on the exact string. If that was the case, it was very simple. Okay. But that's not the case. So in our scenario, the first name can be spelled little differently. Michael can be spelled as Michael, Michel, just giving an example. And we saw the example of how address lines can be spelled differently. So in this demo, what I'm going to show you is, see how patient 1003 will end up matching to 1011 even when there is a slight spelling difference in his last name, in his address line 1, and they will still end up matching. So I already ran this pipeline, and so you can see the patients have matched here, but I'm going to delete this just for the purpose of this demo. So let me just go ahead and delete that record. Okay, so as we can see, that record has been deleted. And now let me explain you how we are going to do it. But before that, I'll just run the pipeline. Okay, well, actually, let me first explain you what we have done. Okay, so I've created this pipeline here called MDM embeddings pipe. Now, what this pipeline does is, so first, it will read from the config. Okay, it will read from the MDM config here. It will read the rules, it will read the rule keys. Okay, so you see here, we open the config file, and then use the JSON.load and load it into MDM config variable, and then we extract the rules from MDM config, and we also extract the persist directory where we are going to store the embeddings for the patients, which we're going to create the embeddings for. We're going to store it here, and then for this demo purpose, I'm using the model all mini LM L6 v2. Now, what we do is we fetch the patients here. Okay, so it's a simple SQL query which says that, hey, give me all the patients for a specific year, and where is active is equal to 1, and is deleted, soft deleted 0. So all the stuff, normal stuff. And this is a method which, once the embedding is done, it goes ahead and marks that patient as embedding done, so that it is not picked up for embeddings again. So yeah, and then this is the function where we create the embeddings for per rule. Okay, and so here this function takes input as the rule name and the rule keys. So if you see, the rule keys are this keys here, so different keys for different rules. Okay, and yeah, it what I've done is it takes all those keys and it joins them together, and that is what the concatenated value is, and that is what we we create the embeddings for the concatenated value, and we store it in our ChromaDB. Okay. All right, yeah, that's in short what we are going to do. But for this demo purpose, I've already ran this pipeline, and the embeddings are already there in the system. So what we are going to do is we are just going to run the MDM matching pipeline. Now, I'm not going to go a lot in details about this, but it's very simple. What it does is, for the same rules, it retrieves the patient records, and in the select clause, it will take all this rule keys that are there, and it will again concat it, and we'll find the embeddings based on that concatenated key. So we will pass that concatenated value to ChromaDB, and it will search for the embeddings, and it will return those embeddings which we have mentioned as top K that we want. So you can ask for top 5, top 2, top 3. It will return that, and then based on the score. So basically, in a high dimensional vector space, so the concatenated value of those embeddings that we have done before, and the concatenated value that we are passing, okay, if there is a match, it will be a match with a score, and the score is nothing but it's a distance of one embedding from with respect to the other embedding, and closer the distance means close the match. Okay, so if you see in this MDM config file, I have defined a configuration here where I said that, hey, auto match it. Okay, I mean, it's just a variable called auto, just a key called as auto match score less than, and I've told it that if the score is less than 0.1, only then auto match it. Else, put it as a potential match if the score is less than 0.2. So between 0.1 and 0.2, then put it as a potential match and not as an actual match. So now let's go ahead and run this pipeline and see what happens. Before that, we have all seen that we have nothing in our MDM crosswalk table. So I'm going to go ahead and run this pipeline. Okay. Let's see what happens. Just go through the logs while this pipeline is running. Okay, so our pipeline has started running. It's loading the MDM config, initializing the vector store. Okay, now it says fetching eligible patients for matching. So it is processing rule 1, and it fetches the keys for the rule 1. Now it's just fetching the details for the patient, and it finds patient 101. So that's a concatenation of client ID and the patient ID. That's a combined key. So it's searching for the similar embeddings, and see here what it says skipping self match. So because we are passing this embedding, it will definitely find one record which matches, and that is the self match, and we don't want to match it on self, so we're skipping the self match. And see, it finds other embeddings as well. Look here, but the score is 0.2690, and as I told you, higher the score, less matching probability. So it says that score of 0.2690 is too high for match, and it is skipping the match, and it does it for all the patients one by one. So let's see, for our patient 1011, it says that, see, it found a match, fetching details for patient ID 11011. It is inserting it in the crosswalk, client ID 1, patient ID 1003, 1011, status is matched, and the score is 0.06. So it is a very good match. Okay, now it is processing rule 2, which is matching on first name, last name, date of birth, email ID. So guys, imagine how powerful it is to store the data in vector databases, use the AI features like cosine similarity, and matching the embeddings. Is very powerful. And if I tell you, companies, there are organizations like Reltio and Verato, which especially only their business is to provide services like master data management, and yes, they provide a very sophisticated algorithm or process for master data management. But imagine how much cost an organization can save if most of the matching is done at their end, and only where some matching if it requires some external databases to match, or if the match is a kind of very complicated where nothing is matching, and that is a very rare scenario, guys. How can there be a case where if suppose patient has some 18, 19 identifiers like first name, last name, SSN, date of birth, license number, first line of address, work phone number, home phone number, there will be, it can be a scenario where maybe 30, 40, 50% of their data points are not matching, but at least 50 will match, right? So I think this algorithm or this process or this pipeline that I've created, it will at least get your 99% work done. So let's see what we have here. Okay, now we see that we have 2 matches. Okay, and the master ID also has been created. So one match is patient ID 1003 1011, which is a perfect match because the score is 0.064 for rule number 1. Let's see, just for the confirmation, what 1003 and 1011 are. And if we see our 1003 and 101, One are the same patients that I showed you, Johnson Robert, 789 Pine Road, and 1011 Johnson Robert, 789 Pine Road. Okay. However, we see that there's another match. So let's see what that match is, which is patient 1002 and 1012. So let's check that out. 2 and 12. Okay. So in 2 we have Smith Jane, Jane, sorry, 456 Oak Avenue. And what is patient 1012? It is Smith Jan, Jan. So spelling mistake, Jane, Jan. And first line of address is 456 Oak Avenue. Avenue is spelled as Avenue instead of Ave. So yeah, we have found 2 matches, and system has marked it for potential as a potential match. So whenever you get a potential match, you can show those matches on the UI, and user can just manually review those matches and then merge it if the user thinks that both of these patients 1002 1012 are the same patients. The reason why it did not match is because the match score is 0.16, which is greater than 0.1, and that's the reason it has been flagged as a potential match, but which is again good, because if there is a little bit of a doubt, we don't want to auto match it, and we want the data steward to go ahead and review the match and take the decision manually if they want to merge it or not. All right, so this is what I wanted to show you guys, and let me know if you have any questions in the comment section, and I'm looking for your feedback. Thank you so much for watching, guys. Have a good day. Bye.